Good morning, everybody. So we're finished off with the introductory notebook for the C programming language. The next notebook in the series is types. There is a PowerPoint lecture that sort of corresponds to this notebook. I think then the material is slightly different between the notebook and the PowerPoint slides. So I've decided to go with the notebook instead. So I'm going to introduce you to the basic data types that you can use in C. Fortunately, for any of you who've taken Java, the way C's type system is similar to Java's type system, right? So just like in Java, every variable needs a type, right? And you declare your variables exactly the same as you do in Java, right? So that declares an int variable x. Now, so that thing there is called a declaration, right? A declaration simply says that a name exists. So this says that the name x exists and its type is an int. Right? Now, when you declare a variable, you can also initialize it. So that is a declaration plus initialization, right? Which is that thing right there. And so that's the way that you would normally declare and initialize a variable in Java, right? It's exactly the same thing. One of the things that a lot of programmers don't realize is that there is a difference between initialization and assignment, right? So that thing there, a lot of programmers will tell you, oh, that's assignment. In languages like C and Java, strictly speaking, that is initialization, right? Assignment is when you have an existing variable and now you give it a value. So that's initialization, that's assignment. So in C, similarly to Java, well, is that true? I'm just trying to think. So in C, there are variables that can be initialized, but they can't be assigned to, right? Is that true? So that's not the case in Java, right? So in Java, you can assign to any variable type, to assign to a variable of any type, right? In C, that's not the case. So in particular, if you have an array in C, right, a variable that corresponds to an array, you cannot reassign back to that variable, right? And so that's you have to be a bit careful about that, right? So assignment and initialization are two different operations. Almost everything, so everything can be initialized. Almost everything can be assigned to except arrays. Okay, so I guess the basic types in C would be the numeric types. So we'll start with the integers. So in Java, there's basically, well, in 124, you basically used int and long, maybe, right? Java also has byte and short, and char is also an integer type, although normally you treat it as a character type. C has a lot more integer types. So notice the table is very long, right? And so C has both signed and unsigned versions of all of its integer types. Right? So unsigned simply means that the value is always 0 or greater. Right? All of the other types, if it's not unsigned, then it's signed, which means it can be negative or positive or 0. Right? Okay, so all of the integer types are as, so there's char, right? So similar to a char in Java, right? There's int. There is long int, which is also long, right? You can just call that long. But you also have the corresponding unsigned types, right? So you have an unsigned char here. You've got an unsigned int there, and you've got unsigned long there, right? So they come in, all of your integer types come in at least two variations, right? Now, the other big difference between Java and C is that in Java, the language says an int is exactly 32 bits, right? Long is exactly 64 bits. Char is always 16 bits in Java. The C language is different. So the C language says char is the smallest. Char is the smallest variable type, right? And it contains at least 8 bits, but it doesn't say exactly what number of bits a char is. And that's because when the C language was created, computer hardware was different from manufacturer to manufacturer to manufacturer, right? And so you wouldn't know. So the computer that you program, one computer that you might be programming on might have a char that's 10 bits wide, and another one might have a char that's 8 bits wide, and another one might have one that's 12. And so there's no fixed number of bits for the types in C. Right? Char is your smallest type. It contains at least 8 bits. Right? Short, or short int, they're both the same thing, is at least 16 bits. Right? Int is at least 16 bits. Right? So it's not necessarily bigger than a short on your computer. Right? Long is at least 32. Right? And then long is at least 64. Right? So the actual number of bits is not specified. You have to keep that in mind. Right? This used to be a problem many, many years ago now, I guess, when you had many different hardware manufacturers. Nowadays, there's basically ARM, Intel, and AMD, plus a few smaller manufacturers. So it's more predictable how many bits an integer variable has on a particular computing system. Right? You can look it up. You can look up the information. So there's a table. I guess we can just hunt it down quickly. No, it's not the right one. There's a table that's documented here, if I can find it. Numerics. Excuse me. Where are the integers? All right, I'll hunt it down some other time and show it to you in the next, I guess, after reading week. Or you can look at it yourself. There is a big table that tells you what are the size of all the variable types for common hardware. Okay, so everything in C, the size of all of your types in the C language, they're all measured as multiples of the size of char, right? So char is the smallest value that you can have. Sorry, it's the value that uses the least amount of memory, right? So by definition, the C language says a char takes up 1 unit of memory, right? So everything's measured in terms of units of char, right? The size of operator tells you how big of a type is, right? So size of char is guaranteed to print 1, right? Size of bool, who knows what that's going to print? I'll explain what bool is in a minute, right? Size of short int is going to print at least 2, right? Because char is 1, short int has to be, sorry, is that true? No, it can print, yes, so it will, that's not true. It can print 1 as well, sorry, right? So however many units of memory that a short int uses, that's the value you get out, right? So size of returns a value. Do I tell you what it is? I don't tell you what it is. Size of returns a value whose type is called size underscore t. So I've got this page handy somewhere. Size t. All right, so that thing size t is one of the integer types, right? And so if you, sorry, let me make that smaller. Okay, so size t is the type that can store the maximum size of a theoretically possible object of any type, right? That changes from computer architecture to computer architecture, right? So on my computer, it might be 2 to the 64, right? On your computer, it might be something else, right? So that's the variable type that can store, that's the type of variable type that you normally would use if you're computing the size of an object, right? So it's often used, right, for array indexing and loop counting, right? So if size t is the type that can hold the largest possible array, right, then size t is also the appropriate type to use as an index when you're looping over an array, right? That is if you don't want to run into any issues of being not able to index into the array, right? So if you use an int, for example, to index into an array, it's theoretically possible that the array might be bigger than the size of an int, which means you can't access all of the elements. Right? Normally that doesn't cause any problems, but I suppose in today's environment it might. Right? Okay, so that's what that thing size t is, if you're wondering what size t is. Right? Now I don't actually mention it on this particular example, but it will show up either in this lecture or the next. Right? And so this little program here simply prints the size of all of a bunch of different types. Right? So we're going to use printf to print the value. Right? Now, printf is your formatted print function. If you were to look up the documentation for it, right, so you'll find that there's a whole family of printf functions. Right? There's a printf, there's an fprintf, an sprintf, and so on and so on and so forth. Right? Printf is the one that prints to standard output. Fprintf prints to a file. Sprintf prints to a string. Right? The other variations here are the quote-unquote safe versions of printf. We don't care about those right now. Right? Okay, so the way printf works is as follows. So they all work a similar way. Right? The first argument is what's called a formatting string. So the formatting string contains any characters that you want to print, plus information about how to interpret the remaining arguments passed to printf. Right? And so anytime you see a % sign, that is what's called a conversion specifier. Right? So %LD means treat the first argument as though it were a long double. Right? So it turns out size of, at least on my computer, it actually corresponds to this value called long double. Sorry, LD. I'm being an idiot. Sorry, LD. This is a long int. Right? So it turns out it's a long int. The D conversion is the conversion that you use if you want to convert an integer and print it. Right? So this is some kind of integer value. Right? The D is saying treat that as though it were an integer. Right? The L is the length modifier, so that's long integer in this case. Strictly speaking, this is incorrect. So strictly speaking, that should be ZD. So Z is a new conversion, is a new length modifier. So new as of C99. That works for size T. Right? LD happens to work on my computer. Right? So once again, that's the formatting string. Any characters that appear in the formatting string appear in the output. Right? Anything with a % sign is some kind of conversion specifier. Right? That tells printf how to treat the arguments that are passed to printf. Right? You'll typically have one conversion. You must have one conversion specifier per argument, per extra argument that you pass to printf. Right? So we'll see more examples where you send several things to printf to print. Okay, so I'm just going to print out the size of a car, a bool, a short int, and so on and so on and so forth. Right? So let's run that and see what we get. Oh, so that's good. So car has size 1. Right? Bool has size 1, so apparently on my computer a bool has the same size as a car. Right? Short int is 2, int is 4, right? And so on and so on and so forth. These funny things down here, so car star and double star, these are called pointers. So if you don't know what a pointer is in C, I don't think we'll get to it today. But a pointer type, so pointers are one of the big differences between C and Java. Right? Java doesn't actually have a pointer type, C does. Right? And so it looks like on my computer, pointers are 8 times the size of a car. Right? So that's what those numbers mean there. Right? Remember, everything's measured in units of car. Okay. So the type bool is a newer type. So it was introduced in C99. That corresponds to logical values, right? So Boolean values, true or false. So perhaps somewhat surprisingly, right, before C99 came out, there was no dedicated type for true or false in C. Right? So C would use basically an int to represent true or false. Right? 0 would be false. Any non-zero value would be true. Typically, people would use 1. But you didn't have to. So C99 introduced a bool, little b OOL. Strictly speaking, it introduced underscore big B OOL. If you ever see anything with an underscore in front of it, that means it's a newer feature that was added to the language. Right? So technically the type is underscore bool, but if you include the header file standard bool, right, you also get a definition of little b OOL. Right? I can actually show you that header file. It's right here. So if you were to go poking around, oh, you can't read that. Right? You can find the source code for all of the GCC for all of GCC. So its header file, standard bool, looks like this. Right? We'll talk about what this is later on in the course. For now, it's just there. Right? Here, you can actually see the declaration of bool and the corresponding declaration of underscore bool. Right? Notice that it's simply defining true to be equal to 1 and false to be equal to 0. Right? So even though there's a type called bool, it's actually still an integer type. Right? That's very different than Java, right? So in Java, you have true and false, and you can't convert Booleans to integers or integers to Booleans in Java, right? That's not true in C, as you'll see in this example. Okay, so I'm going to make a little bool variable called flag. I'm going to set it to true, right? Here's your if statement. If statements work exactly the same in C as they do in Java, right? So if the flag is true, I'm going to print true. Otherwise, I'm going to print false, right? This should print true, and it does, right? Now the rule for bool is that you can use true and false, right? So that should print false, right? However, you can use any numeric value here that you want, right? So if the value is 0, right, that's false. Anything that's not 0, whether it's an integer or not, is true, right? So 1 is true, right? -1 is true, right? Minus 0.999 is also true, right? So any non-zero value is considered to be true, right? And is automatically convertible to bool, right? Strange but true. If you go the other way around, so if you go from bool to an int, for example, false is 0 and 1. False is 0, true becomes 1. All right, so if you want to print out a Boolean value, so you're debugging your program and you would like to know what is the state of your Boolean value, right? Unfortunately, there's no conversion for it, right? And so the printf function predates the type bool, so they never added a conversion for bool. So you're stuck printing out an integer in the simplest case, right? What integer do you print out, or how do you print out an int? So %d and %i will handle signed integers. %u is the conversion that you can use for an unsigned integer, right? Bool is an unsigned value, so all three of these work, right? So for example, I can use %u, right? That tells printf to interpret that value there as an unsigned integer, right? And it will print it out as 1. \n prints out the new line character, right? So this prints out true or false, 0 or 1, and then goes to the next line. Right, so false is 0, right, and true is 1, right? D or I also works here. They'll do the exact same thing, right? You can use any one of those three, right? Now, this isn't the greatest output for a Boolean value, right? You have to remember that you're printing out a Boolean value and not an integer value here, right? If you actually wanted to print it out as a string, there's no convenient way to do it. So if you actually wanted to print out true and false, you've got to do some work on your own, right? And it turns out the minimal amount of work you have to do is the following. Right? So here I'm going to print out the string true or false. So that's a string, so I need %s as the conversion, right? Now, I want to print out the string true or false. So what I'm going to do is use C's trinary operator here. So this is something I normally don't show in SISC 124. It exists in Java, right? But this thing here is essentially the short form for if something, do something else, right? So that thing there is a condition, right? Anything that evaluates to true or false, right? Question mark indicates that this is the trinary operator, right? Okay, so if that thing's true, then the value of this entire expression is the string true, right? So the thing I just highlighted is the value of the overall expression, right? In this case, it's a string, but it could be anything else, right? You could make it an int, you can make it a double, whatever you want, right? That's just some value there, right? If the flag is false, so the colon is the else part, right? So if flag is false, then this whole thing evaluates to the string false, right? So this will print either true or false depending on the state of flag, right? So if the flag is false, it prints out false. If the flag is 0, it prints out false, right? If the flag is 99, it's going to print out true, right? So there's a trinary operator. There's your conversion for printing out a string. All right, so cars in Java, in C. So cars in C are just plain old ints, right? Most commonly, they're used to represent characters in a string, so similar to Java. Right? You can have a car literal just like you can in Java, right? So anything inside, any single character inside single quotes is a car literal, right? You cannot have the empty car literal, right? So single quote doesn't work, right? That's a compile time error, just like in Java, right? If you want to print out a car literal, use %c, right? So there's my car x, right? Using %c, right? So treat c as though it were a car, print out the car. So this should just print out x, and it does, right? Now remember, cars are just integers, so you could try using %d here or %i, right? And if you do that, you get a different result. Oh, sorry. Right? Now you get 120, right? And so there is an example of how this conversion specifier works, right? That's actually a car value, but %d says treat that car value as though it were an integer value, right? And print it as though it were 1, right? And so it takes whatever value is actually stored in C, which I guess in this case is 120, and prints that out instead, right? %c says treat that as though it were a car value and print out the car representation of that value, right? So its numeric value is 120, but when you print it with %c, it prints out as x, right? The printable version, right? So there's your difference between %c and %d. Right? Again, there is no such thing as the empty car, right? So if you try to do that, you're going to get an error, right? Error, empty character constant, right? So you're not allowed to have an empty car. You can have a space, that's fine. This is going to print out a space which we can't see, right? But you can't have the empty car. Okay, so there are some characters that are useful that you want to be able to use at some point in time, but you can't use them directly in a string or in a part of a character, right? And so for those characters, you need to escape them, right? So \quote is the single quote, right? So if you wanted the character that corresponds to the single quote, you have to write that, like that, right? So the reason you have to write that is because if you don't have the \, it looks like quote, 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 which is not allowed, right? That quote, quote to the compiler looks like an empty string, looks like an empty car, which is illegal, right? So you need to indicate to the compiler that this character is in fact significant, right? And that's the \. Right? So that works fine. Right? The double quote is \, double quote. Right? Otherwise, the double quote is interpreted as the start of a string. Right? Surprisingly, the question mark you need to escape if you want it as an individual character. That's because there's these things called trigraphs in the language, which we'll never look at, and you will probably never encounter, but they do exist. Right? \/ is the backsplash. And there's a bunch of other characters that are occasionally useful. \n is useful, right? So that's the new line character, so that shows up a lot. \t is the tab, the horizontal tab character, right? So that often shows up as well. Okay, the integer types. So you've got both signed and unsigned varieties of all your integer types, right? They behave. So the unsigned types are always 0 or greater, right? The signed types can be negative or positive, right? Besides that difference and the fact that they don't have a specified size in C, they behave the same as they do in Java. So all of the overflow issues that occur in Java also occur in C. To print out a integer value with printf, it's %d or %i for the unsigned types, right? Now, depending on the exact integer type, you might have to specify a length. You might have to specify a length modifier, right? So for example, short int, if you try to print it out, you should use the conversion specifier h and then the I. Don't memorize all this stuff. You're just going to look it up, right? No one's going to ask you about this on the test, right? %li will print out a long int. If your architecture has access to it and you have long int, that's LLI. Right? So occasionally you will see, right, something like HD. Right? The D is the specifier, the H is the modifier. Right? So here we're going to print out a car as a integer, I guess. We're going to print out a short value. So short values are H. Your modifier is H. An int value is D. Long int is LD, and long int is LLD. Right? Run that, and not surprisingly, you get the values that you expect. Right? Again, when you print out a car using %d, you get its numeric value instead of its printable value. All right, so if you took Java with me, then I would have told you about the enumerated types. Right? So in Java, you've actually got a reference type that represents enumerations. C doesn't have that sort of thing. C does have an enumerated type, but it's really just an int. Right? So if you have a small number of constants that you want to give a name, you can use this thing called enum. Right? So enum day, brace, brace, and then you list your constants inside the braces. Right? So my days are Sunday, Monday through Saturday. Right? Your constants are all integers. Right? So you can assign them a value if you like. Right? So enum compass, so these are your 4 compass directions. Right? So north is 0 degrees, east is 90 degrees, south is 180 degrees, west is 270 degrees. So that's fine. Right? The values don't have to be in order. Right? So it doesn't have to be 0, 90, 180, 270. You can assign them whatever order you want. Right? If you assign one value, like that, then all of the following values get assigned. Then February will get the value 2, March will get the value 3, April will get the value 4, and so on and so on and so forth. In the first example, Sunday gets the value 0. Right? Okay, now your type name becomes enum day. Right? So each one of these is declaring a name for a type, right? So it's not just plain old day. Your type is enum day, right? It's not just plain old compass. It's enum compass, right? So I can make a variable d whose type is enum day, and I can assign it a value. Now the problem is you can assign it any integer value because this thing really is just an int, right? So there's only 7 days, but I can go ahead and assign the value 10 to d, and there's no problem. Similarly here, for dir, I can assign it the value south, but I could also assign it the value 1 million, and that's also not a problem. Right? Month, I assigned October, but I could also assign it Saturday, for example, and that would also work. Right? Again, because they're just plain old ints. Right? So d is 10, okay. Dir is 180, which corresponds to south, great, and the month 10 corresponds to the month October. So yes, there are enumerated types. Yes, they make your code a little bit easier to read. They're not type safe at all, right? They're just plain old ints. Okay, there's not much to say about the floating point types. They work exactly the way they work in Java, right? So float and double in C work exactly the way, same way as float and double do in Java on a modern computer. Right? Modern computer, modern compiler, right? They all follow IEEE 754 for the floating point types. Right. If you want to print out a floating point value, your conversion specifier is normally %f. Right? So %f will give you will print out a floating point value. %e uses what's called exponential notation. So I'll explain what that is in just a second if you're not familiar with it. %g tries to choose the best representation between %f and %e. So here's my value of pi. Notice it's got lots of digits in it after the decimal place. When you print it out, though, right, by default, you only get 6 digits after the decimal place. Right? So you only get 6. even though the digits 6, 5, 3, 5 are really stored in the value pi. Right? %e uses what's called exponential notation. So in exponential notation, you get one digit followed by a decimal place, followed by, in this case, 6 digits. Right? So it's that number. The e means times 10, and then the integer here is the exponent. Right? So this is 3.141593 times 10 to the power 0. Right? And then finally, %g tries to compromise between these two. The algorithm that it uses is not super clear. It basically looks at the magnitude of these two values and then tries to pick, and tries to decide whether or not it should use %f or %e. Right? Okay, so you only get 6 digits, which may not be enough, or you may not want all 6 when you're using this conversion. Right? So you are allowed to tell printf how many digits should you actually print when you're performing the conversion. Right? So the way you do that is you write dot, so the decimal place, followed by the number of digits you would like. Right? So this is called the precision of the floating point conversion. So dot 1 means give me 1 digit after the decimal point. Right? Dot 10, means give me 10 digits after the decimal point. Right? Dot 100 means give me 100 digits after the decimal point, although it's not clear that that ought to work. Right? So let's see what you get. So it turns out you do, in fact, get 100 digits after the decimal point on my computer. Right? These digits are not necessarily accurate. So that's something you have to keep in mind. Right? So 1 digit, 10 digits, and then some very large number of digits. Now, when you're working with double and you're treating it as a base 10 value, you've only got so the value is only accurate to 15 to 17 digits. Right? So printing out 100 is more or less meaningless. It doesn't tell you anything useful. Right? But that's how you specify the that's how you specify the precision for a floating point value. All right, so C also has this thing called const. So a variable in C can be labeled or qualified as being const. And what that means is that the variable becomes unassignable. Right? So in other words, it's read-only. So if you mark something as const, you must initialize it as well. Right? Otherwise, otherwise it's sort of useless to you because you can't assign it a value. Right? So it's initializable, but it's not assignable. Right? So here's an example of a variable type that is not assignable. Right? So normally you use this sort of thing when you have a variable and you want to make sure its value never changes. So something, for example, like pi, right? Which, believe it or not, is not part of the C standard library. Right? So if you want to use the value pi in your program, you're probably going to declare a constant somewhere called, in this case, big Pi. Right? You're going to write down the digits of pi as best you can. Right? And then you're probably going to label it as being const, right? Because you don't want somebody accidentally changing pi on you. Right? So const double pi means pi gets that value and is stored in read-only memory, right? So it can't be changed. If you try to assign it a value, the compiler will flag that as an error. Right? Okay, if you want to do any math in in C, right? All of the standard math functions are declared in the header file math.h. Right? So if you want to do something like compute the cosine of an angle, right? Include the header math.h, and that will provide the standard math functions to you. Right? So things like square root, power, so pow for exponentiation, and a bunch of other things are all declared in that header file there. Right? So this is going to print out the sine and cosine of 30 degrees. Oh, or not. Undefined symbol cos. Oh yeah, we need to link. Is this going to work? This should. Is this? I just want to see if there's actually a note here that says. Does not. I thought this was resolved. So this is. I guess I should show you this in the terminal. Wait. All right. Where am I? C, yes, source types, right? Is it here? Print. Array, boo. Sorry, I just need to know what this thing's called. Const, okay. There it is. Okay, so const.c. Okay. So I'm going to compile this here. Const.c. Okay, there you go. So when you try to compile this on the command line, you'll notice that you get an error. So this is the same error that showed up in the notebook, right? So what's happened here is that we've used some of the functions from the math library, right? So we included math.h, and our program includes a reference to cosine and a reference to sine, right? So when you compile this in the way that I showed you here, right? The compilation works, but then it fails at link time because it doesn't know where to find this function cos and where to find this function sine, right? So this is one of the cases where you have to tell the compiler where is the library that contains cosine and sine, or what file contains cosine and sine, right? And so the way you do that is you tell it, so minus L, right? That's an L, not a 1, right? So minus L. So that is short for link, right? And so the M is the shortened name for the math library, right? So minus LM, link to the math library that contains cosine and sine, right? Now it compiles completely cleanly, and you can now run const. Right? So that prints out the cosine and sine of 30 degrees to 6 digits. Right. Okay, so what happens if you try to reassign to pi? Right. So if I try to reassign to pi, right? Remember that we marked pi as being const, so that line there should cause a compiler error, right? And it does, right? So you get an error assignment of the read-only variable pi in this case, right? So const means you cannot reassign back to the value, right? It can be initialized, can never be assigned to. All right, void. So Java also has the void type, right? So in Java, if you have a method that returns void, you know it returns no value, right? So in C, it means a similar thing, right? Void means cannot hold any value, right? So you can use it as a function return type to indicate that the function doesn't return any values, right? You can also use it as the single parameter in a function to indicate that the function has no parameters, right? Takes no arguments. There's also something called a void pointer, which we're going to talk about when we talk about pointers, right? You are not allowed to ask for how big is void, right? So that always gives you back an error. All right, arrays in C. So Java has arrays, C also has arrays, right? There are significant differences between arrays in C compared to arrays in Java. Right? So first of all, the similarities, right? They both represent a contiguous sequence of objects all having the same type, right? So contiguous just means that they come one after another in memory. The capacity or the length of the array never changes over the lifetime of the array, right? So just like in Java, you make an array of size 10, it's an array of size 10, right? In C, an array of size 10, always an array of size 10. Both languages only allow a single type in an array, right? So you have an array of int, you can have an array of char, you can have an array of double, right? And you use square brackets to access the individual elements, right? So accessing and setting elements of an array looks exactly the same as accessing and setting elements in Java. Okay, there are some very significant differences though. Right, so in Java, you can make an array variable and then reassign it so that it refers to a new array, right? So in Java, you could write something like the following. So you could write something like int square bracket a, and then in Java you would write new int 3, something like that, right? Java lets you reassign a. So you can say a now is a different array, right? So now it's an array of length 10, right? That reassignment is not allowed in C, right? So in C, you cannot assign to an array variable, right? You can initialize the elements of the array, right? But you cannot reassign to the array variable itself, right? So that's a fairly big difference, right? In C, if you know how big the array is, it can be part of the declaration. So I'll show you an example of that shortly. The other really big difference is that in C, the language never checks your indexes for you, right? In Java, if you were to use the index 11 or even 10 with a, right, you would get an index out of bounds exception, right? If you use a negative index, you would get an index out of bounds exception. C does not do any index bounds checking, right? If you use an index that is not valid for the array, something happens, right? Whether something sensible happens, well, it will never be the case that something sensible happens, but something will happen, right? You will not get an exception. If you're lucky, your program will crash immediately. If you're unlucky, your program will keep running and you'll never know that there's a problem, right? So the C language, the philosophy of the C language is if the programmer wants some feature, they're going to have to ask for it. If you want to check your indexes, you have to do it yourself, right? The language won't do it for you. Okay, so in C, an array degrades to a pointer to the element type when the array is passed to a function. All that means, so I'll talk about this in greater detail later on. If you have a function that expects an array, it doesn't actually get an array. It gets something else, right? If you have a function that wants to return an array, it turns out you can't return an array from a function. You have to return something else, right? We need to talk about pointers before those 2 points make sense. All right, so here's how you make an array of a fixed size in C. Right? Notice in Java you have to use new here, right? In C, if you're going to make an array like this, you simply say how big is the array, right? And you'll get an array of size 3, right? So that one line of code makes an array of size 3, right? It actually has 3 ints in it. You don't know what they are, right? So these are not guaranteed to be 0. Right? In a small program, they often will be 0, but there's no guarantee that they're 0. Right? So don't assume that they're 0. They're not initialized yet. Right? There's assigning the 3 values, so you could do this. This is exactly the same way you would do this in Java. Right? There's accessing each value. Right? Again, exactly the same way as you do it in Java. So this loop just prints out the 3 values, one value per line. Right, so this will just print out 1, 2, 3, like that. Right? Okay, so if you have an array that's declared like that, right, you can use size of on that variable, right? So size of returns the total amount of memory that's used by the entire array, right? So it doesn't tell you how many elements are in the array, right? It tells you the total amount of memory that's used by the array in multiples of car. Right? So this thing here, right, array of size 3, right? If I ask for the size of x, right, that is 3 times however big an int is. Right? So the size of that array is 12 units of memory, right? I guess on my computer an int is 4 units of memory. So that total array takes 3 times 4 units of memory, or 12. Right? If you actually want to know what is the capacity or length of the array, right, you have to divide by the element type. Right? So size of x divided by size of int, that'll tell you how big the array actually is. Right? So that tells you it's 3 elements long. Right? Now that I've shown you that, never write this. Right? So forget I just showed you this. Right? There's a big box here that explains why you should forget I just told you that. Right? Okay, so now that you know what size of does, when you give it a local array variable, right, you should remember to never use size of to actually determine the size of an array, right? Right. So in this program here, you know that array has size 3, right? You wrote this code, right? This function hasn't gone anywhere, right? That array has size 3. You shouldn't have to compute it, right? There's no reason for you to compute this. The problem with that new programmers new to C will make is that they'll write a function, right? Their function will take in an array, and then they'll say, hey, I can do this to get the size of the array, right? And it turns out that never works if you do that, right? Because of the way that arrays are passed back and forth from a function, right? So this never works when you want it to, right? You don't need it here. When you do need it, it doesn't work, right? So everything I just told you, just forget about it, right? I'm not going to ask you about it. If you use it on an assignment, you're almost certainly screwed up, right? Don't do it. Right. All right, no array index bounds checking. You're really going to miss Java and Python in this course, right? You're going to write some code that loops over an array, and it's just going to do something weird, right? It'll run, it'll give you some strange result, or it'll crash if you're lucky. Right. So here's an array of length 5. It's got 5 nines. Oh, this is how you initialize the elements of an array if you want to initialize the elements at the point of declaration. Right. So it's just like Java. Brace and then put the elements inside. So there's an array of length 5. Right. I'm going to look at the first element in the array. Right. So the array element at index 0. Right. Here's an array of length 3. Right? I'm going to assign to the first, second, third, and fourth element, right? That's assigning to the fourth element of the array, but the array only has 3 elements in it. Right? Does the program compile? You betcha. Does it run? It sure does, right? There's no test here as to whether or not that was legal. Right? Okay, so what actually happened here? So remember back here, right, I made my array 1, right? I set all of its elements to -9, right? And I printed out the value of array 1, the first element, right? It's -9, right? I then made another array of length 3, but I assigned to the fourth element, right? Look what happens when I print out the first element of the first array now, right? The first element of that first array is no longer -9, it's the 4 that I wrote here, right? So what's happened here is that when you access the fourth element of x, you actually wrote into the first element of the array 1, right? You blew over some other variable that you had, right? Which is no good, right? In Java, this would never happen, right? Python, this would never happen. In C, this exact thing, this will happen. Right? You can write past the end of an array, right? And you will end up writing into something that you probably didn't want to write into, right? Here we ended up writing into the second array, which is definitely not something we wanted to happen, right? This is a source of many, many, many security bugs in the C language, right? It's called a buffer overflow error, right? You've written past the end of your actual array, right? So the language, there's nothing in the language to help to stop you from doing this, right? If you're lucky, your program crashes. Ours didn't crash, right? And produced a very strange result. All right, so it's 20 after the hour. I guess I should stop there. If you thought arrays were bad, you're going to hate strings. But anyway, we'll talk about that after reading week. Your third assignment is available to you. I did move the assignment due date so that you have a sufficient time to do the assignment. Right, it is a bash assignment, and so it's out now. All right, so that's all we have for today. I hope everybody has a good reading week.